Here's a shameless plug for my new book. I started it 3 years ago, and it was finally released last Friday, the 13th of January, 2023. Here's a picture of the front cover. It's available as a Kindle ebook on Amazon, as a Nook ebook on Barnes & Noble, and on Kobo.com for about $4. The paperback versions are only available on Lulu.com. The color paperback is available for about $20 and the black and white for about $15. I will leave links below for those items. The cover needs some explanation. NavDEC refers to the Navy, NAV, and DEC refers to Digital Equipment Corporation, DEC. The profile of the airplane on the top is an A3D Sky Warrior representing the first half of my Navy experience. The second aircraft is an A6A Intruder representing the last half of my Navy experience. The large digital logo represents the 30 years I spent at Digital Equipment Corporation. Hence the title, NavDEC. This particular Sky Warrior is one from my squadron, VAH-4, affectionately known as Heavy 4. We love this airplane. This particular Intruder is one from my squadron, VA-52. Some folks thought the Intruder looked like a pregnant guppy, but we thought it was beautiful. The last half of my book talks about my 30 years in DEC, first as a hardware instructor, then as a software engineer. The ones and zeros for the background on the front cover have a meaning that is left as an exercise for the reader. There's an ASCII chart in the back of the book. The back cover of the book. The top half represents the beginning of my Navy career, where I was taught the bombing problem. The Navy bombing computer in the A3D Sky Warrior was this mechanical analog computer, the CP66. The bottom half of the cover represents a small sample of computers that I taught, repaired, and programmed. Here's the first half of the book, Table of Contents, which covers my Navy experience only. Each chapter tells of my journey, adventures, and mishaps along the way. The second section of the book, this Table of Contents, again, each project in my computer career is covered, showing my accomplishments and failures along the way. The book is 364 pages long and contains 198 pictures. Here's a slideshow showing some of the pictures from the book. Here I am in boot camp at age 17. Yes, I was very young. When you graduate from boot camp, you are an E2. You get 2 stripes. The color of your stripes represents what part of the Navy you are in. In my case, they decided I should go in into the Naval Aviation branch, so I wore green stripes. At this time, I was an airman apprentice. After a few months, I was promoted to airman, 3 green stripes. Then I was sent to Softly Field near Pensacola, Florida. This was a base that trained Navy pilots to fly. I had a choice of working in the galley or being a plane captain. I chose plane captain. If there was one thing I learned in boot camp, I wanted nothing to do with the galley. This is one of the over 100 T-34 Mentors that I became a plane captain on. My job was to gas it up, check the oil, taxi it into and out of the tarmac. Finally, I got to run the engine and test it each day. I would strap in the pilot and student pilots and greet them when they returned from their flights. Also at the base, we had a lot of T-28 Trojans. The students took their first flights in the T-34, but then they advanced to the T-28s. They were much bigger and much more dangerous. These are the first Navy patches that I sewed onto my working jacket. The T-34 squadron was VT-1, or TRARON 1, which meant Training Squadron 1. The training in Pensacola was called PSI, Preschool Indoctrination. After 6 months in Pensacola, I was sent to NAS Memphis for electronics training. Another patch on my working jacket, Naval Air Technical Training Command in Memphis, Tennessee, called Navy Memphis. I was to become an AQB, Aviation Fire Control Technician, Bomb Director Systems. The symbol of my rank was a theodolite on wings. I'll tell you all about the theodolite in the book. After many weeks of training on aircraft systems, then electronics, eventually we got into specialized training. The first thing a fire control technician had to learn was the bombing problem. We spent 2 weeks going over the math. On the right side of the cockpit of an A3D Sky Warrior sits our CP66 ballistics computer. Mechanically, it solves the bombing problem we spent weeks learning. I'll talk about how it does this in the book. This diagram represents how the CP66 does mechanical addition and subtraction with gears. This diagram represents how our CP66 did integration and differentiation. And this diagram shows how the CP66 could do multiplication and division. This large piece of paper on my floor is a data flow. We kept them folded up and in our jacket pocket. This represented the entire bomb director system of the A3D Sky Warrior, the radar, periscope, and the computer. This was basically our schematic, and we used it to troubleshoot the whole bomb director system. Every fire control technician had one of these in his pocket when he was troubleshooting. This is a version of the file that I'm working on to produce one large one to put on my wall. They were 17 inches by 82 inches wide. Coming out of training in Memphis, I extended my enlistment to become a third-class petty officer. That was a little controversial at the time. My friends thought I was crazy. Then we went to Whidbey Island, Naval Air Station Whidbey Island, for more training. This was VAH-123, a training squadron for heavy attack aircraft, specifically the A3D Sky Warrior. Here is a beautiful shot of a Sky Warrior from my future squadron, VAH-4. It was the largest carrier-based aircraft in the world with a wingspan of 72.5 feet, 22 meters. So it was a bit of a handful to land, earning it the nickname Whale. The Sky Warrior was the Navy's first plane designed to carry nuclear bombs. The bomb bay was quite large by Navy standards. It was capable of carrying 12 500-pound bombs, 4 to a rack and 3 racks, one behind the other. All our planes were modified such that the rear 2 racks were removed and a tanker package was installed in its place. We could carry 4 bombs, but also complete tanker missions. The Sky Warrior still holds the world record for the heaviest catapult launched from an aircraft carrier, 84,000 pounds in 1959. Its empty weight was 39,327 pounds. Here's a picture of Deception Pass Bridge. It connected the north part of Whidbey Island to the mainland. Rumor was that one pilot flew an A3D Sky Warrior under the bridge. You can fold the wings and the tail of the Sky Warrior to fit in smaller places, like this building or in the hangar deck of an aircraft carrier. This is part of the flight lines on Whidbey Island used by Heavy 4, my future squadron. Here is an A3D tanking an A3D. This is an RA-5C Vigilante. Aviation Fire Control Technicians, AQs, who were stationed in Jacksonville, Florida, worked on these planes. Here's a picture of an A3D Sky Warrior tanking a Vigilante. Last but not least, I'm out of training and into a real attack squadron. Yet another patch for my working jacket. Here's a picture of a VAH-4 Sky Warrior dropping a 2,000-pound bomb. This plane did not have the tanker package installed, so it could hold the longer 2,000-pound bombs. Eventually, I was deployed with Heavy 4 Detachment Golf aboard the USS Oriskany. On board, we had several different planes for me to learn about. Here's a picture of one of the Oriskany's AD-1 Sky Raider aircraft. The attack jets on board the Oriskany were A-4 Skyhawks. We called them scooters. They did not have nose wheel steering, so the yellow bar laying down attached to the nose wheel was held by a crewman and steered the aircraft while taxiing. The fighter aircraft on board the Oriskany were all F-8 Crusaders. During takeoffs and landings, they would raise their wing up out of the fuselage to increase the angle of attack. Here you can see the red paint on the raised wing just behind the pilot cockpit on the top. They carried air-to-air missiles and 20mm cannons. One of our first ports of call was Subic Bay in the Philippines. Just outside the Navy base gate is Olongapo City. To get into Olongapo, you cross this bridge. They called the river Shit River, presumably because raw sewage was dumped into it. The kids would beg for money, and us sailors would throw quarters in the water, and they would dive for them. Downtown Olongapo was wall-to-wall jeepneys. These were jeeps left in the Philippines after World War II. You could ride just about anywhere in town for a quarter, but you always had to argue with the jeepney driver when you got to your destination. They would claim you promised them $1, when indeed you said a quarter right from the beginning. This is me pointing to a broken nose wheel rim on a Sky Warrior. The green shirt identifies me as a maintenance technician. When our Sky Warriors landed in the Philippines, they had to deploy a drag chute because of the short runway. When a Sky Warrior had to take off from a short runway, they used JATO bottles, called jet-assisted takeoff bottles. This picture above was some test. We used JATO bottles in the Philippines, but only one bottle on each side. Nothing as elaborate as this arrangement. This is me on the fuel probe of our Sky Warrior. This is an F-8 Crusader on the catapults in full afterburner. The blast deflector is used to protect the aircraft on the flight deck. I was frequently on the flight deck behind one of these launches, and it got so hot that you thought your skin was going to start on fire. Then they fired the cat and lowered the blast deflector, and the cooler air would come down the deck and cool us off. It was quite a relief. This is the Oriskany doing underway replenishment. We did this every day. One day we took on fuel, like above. The next day we took on food. The next day we took on weapons. The tail of our Sky Warrior hanging out over the edge of the flight deck was our normal parking spot just behind the island. In the very tail was a power supply for our bomb director system called the modulator. I would have to stretch out from the catwalk to open this hatch in the tail of the plane. Then I would swing out over the ocean and crawl up into the tail to remove the bad modulator. Then I would lower the modulator down and swing it back to a fellow fire control technician in the catwalk. Lastly, I would swing down from the hatch and swing back into the catwalk. Sounds scary, but I was 17 and I thought it was a great adventure. This is the way we transferred people between ships. Here we are sending or receiving this fellow from another ship. If your enlistment was up during an at-sea period in the South China Sea, the only way to get home was to highline to a destroyer, and they would drop you off at a Navy base to fly home. Because the highline transfers were fairly dangerous, many sailors would extend their enlistment for the duration of the at-sea period to avoid the highline transfer. When in Japan, I bought my first 35mm single lens reflex, a Yashica J5. In Hong Kong, I purchased a Yashica Electro 35. It was the first electronically controlled camera. This is the Oriskany anchored in the middle of Hong Kong Harbor. I took some great night pictures from the deck on a tripod with the Yashica Electro 35. As I understand it, Hong Kong never allowed another aircraft carrier to anchor in the middle of the harbor. I believe we would swing on our anchor and sweep the entire portion of the harbor. This is a picture of the escalator on the Oriskany. Yes, all aircraft carriers have escalators. This is to get the flight crews from their ready rooms below decks up to the flight deck. When you are wearing a flight suit and maybe a pressure suit and a parachute, This makes the path to the aircraft easier. There wasn't an up and down elevator. There was just a switch at each end, and you would turn it on to go up or down on the same escalator. While on the Oriskany, I had the opportunity to take a joyride in an A3D Sky Warrior. This was a thrill of my life. I have lots of pictures describing this experience in the book. 0 to 140 in 4 seconds. While landing and catching the arresting cable, we came from 100 miles an hour to 0 in 2 seconds. One chapter in the book is about the fire aboard the Oriskany on 26 October 1966. 44 men died, and it was a tragedy that I think about every day. I wish I didn't. I did a lot of research about the fire, and my view has changed from what little I knew at the time, but my explanation of the event does not agree with the Navy's official investigation at all. After the Oriskany fire, I was back on Whidbey Island. On leave, I married my wife, Pat. Here we are in our first car. We had a Honda Scrambler like the one above, and yes, we did wear helmets. I sold the Honda Scrambler to a friend and obtained his Nichromat single lens reflex. I thought I was in camera heaven. On April of 1967, I was promoted to second-class petty officer. Like it or not, all AQs transitioned into A6A intruder squadrons. This was a disappointment to me at first because I was trying to become a third crewman on the A3D Sky Warrior. Well, now I had 3 more patches to add to my working jacket. This was a Grumman promotional photo showing the diverse weapons load that an intruder was capable of. It is my understanding that the intruder was the first Navy plane that could carry more than its own weight in weapons. One characteristic of the intruder was the wingtip speed brakes. All of the intruders I worked on had them, but in later years they were removed from newer aircraft. Here's a picture from the Microsoft Flight Simulator showing the cockpit of an A6A intruder. The green display on the left was known as the VDI, the Vertical Display Indicator. The display on it was called the highway in the sky. The ground texture and clouds were computer generated. If there were hills or mountains, they were detected by our radar and would be displayed in varying shades of gray. Well, actually green. This allowed the A6 intruders to attack at low level at night in the middle of a rainstorm. They could fly between the hills and mountains using the VDI. Rumor was the North Vietnamese got wise to us and started stringing cables behind the hills to knock down these types of aircraft. The right side of the cockpit is the Bombardier Navigator console to our computer. Here is where the real Bombardier Navigator, called the BN, controls the cockpit. The whole system was called the DIAN system, which meant Digital Integrated Attack Navigation Equipment. In 1967, I re-enlisted for another 4 years. Now I'm at sea with VA-52 aboard the USS Coral Sea. This picture is from Vulture's Row, looking down on the flight deck forward. The planes in the middle with their wings folded are our A6A intruders. This is me on Vulture's Row. In front of me is the SACE bench. This is where we repaired all of the DIAN computer modules. I am stretching up to record a reel-to-reel audio tape from one tape deck to another. The round globes are Navico 101 speakers. I wish I'd never sold them. Here's another view of the SACE bench with 2 tape decks above it. On the Coral Sea, our fighter aircraft were F-4 Phantoms. During carrier qualifications, we saw a demo where an F-4 pilot launched from the catapult and went straight up until he was out of sight. Pretty impressive, although he had to come back down soon for more fuel. In Japan on Liberty, I purchased my first twin-lens reflex with 3 lenses. Seemed like a good time to also buy a spy camera. And of course, a movie camera. About this time, I was promoted to first class. It wasn't a simple promotion. There was controversy, and it was a sad time in my life. You'll have to see the book for details. On Liberty in Hong Kong, our method of transportation was via rickshaws. We could get anywhere for 1 Hong Kong dollar, which was about a quarter. We would hire 2 rickshaws and try to convince our drivers to race, offering the winner an extra Hong Kong dollar. They pretended to race, but probably went about the same speed without the incentive. When we docked in Singapore, we were transferred from the carrier to shore by these LCVPs, Landing Craft Vertical Personnel. It was a heck of a ride. At the end of our cruise, on the way home, the USS New Jersey was in the South China Sea with us during most of the cruise, but we only saw it while in port. While we were on our way home, the New Jersey was steaming along beside of us. We were about halfway home from Vietnam when on April 3, 1969, North Korea jet fighters shot down an unarmed EC-121 Constellation electronic surveillance aircraft. The New Jersey was ordered to turn around and go back into combat. We felt sorry for the sailors who had just had their time away from home extended. Here we are on the USS Coral Sea returning from Vietnam, going under the Golden Gate Bridge. We were the first intruder squadron in Vietnam. No one was happier to get home than me. Now it's time to hop in our Corvette and change duty stations. We left VA-52 and NAS Whidbey Island and headed for NAS Oceana in Virginia Beach, Virginia. In our 4 years in Virginia, we went through 3 cars and 1 camper. Near the end of my enlistment, I was sent to Grumman Aircraft Corporation on Long Island, New York, for training on a new radar system. There we met the test pilots for the then new F-14 Tomcat. Here's a picture of one climbing out in full afterburners. I think this is a Tomcat busting through the sound barrier. With their wings folded, they could really squeeze into flight deck space of an aircraft carrier. Finally, after years of desire, I managed to snag a brand new Leica M2R in a camera store in Norfolk, Virginia. Just before my enlistment was up, I spent some time on the job training with some vast tech reps. The system was in its infancy at the time and was mostly down during needing maintenance on itself. Years later, VAST would become the standard for fixing electronics devices in the Navy. Time to prepare my resume to leave the Navy. It was a good ride, and I left with pride. Now on to Digital Equipment Corporation. We seldom called the company Digital Equipment Corporation. It was always referred to as either DEC or Digital. The little town of Maynard, Massachusetts was a boom town with DEC there. My first job was teaching maintenance to DEC field service engineers on the PDP-8. I also got to learn and play with DEC's largest computer at the time, 1973, the DEC System 10. This was the instruction set for the PDP-8. I knew it by heart. The input to all of our computers at the time was via teletypes. While I was teaching PDP-8s, I started taking night classes at Boston University. Eventually, I received a BScs from them. After teaching a couple of years, I was transferred to the course development group and developed DEC's first course on a floppy disk drive. In this case, the device was an RX-01, which of course only took the large 8-inch floppy disks. The smaller ones didn't come up till years later. DEC headquarters, engineering, and manufacturing were all in the woolen mill in Maynard, Massachusetts. After 2 years of educational services as a hardware instructor, I changed to software engineering. Over the years, I had various offices in the mill. DEC took great pride in their clock tower. It was wound every day. I was in the Memory Test Systems group and wrote various programs to test memories. DEC started becoming the world's largest manufacturer of terminals. These VTO5 were a pleasure to use from our old teletype days. DEC RPO6 disk drives held 176 megabytes on 20 surfaces. And the platter, it was a 20 surface platter that was the size of a large angel food cake. See the plastic container on the right above them. At one point, I had to write a test program using memory management registers to store the program and data. This would have been easy, except every other location was a special register that could only represent a 0 in bit positions 15, 5, and 4. It was quite the challenge to write a program that every other word had restrictions on what bits could be there, but I managed to do it, and it was successful and ended up shipping on all the PDP-1170s for years afterwards. In 1979, my working everyday computer was a VAX 11780, where I started on a 4-year-long project codenamed Hydra. It was to be DEC's first highly available computer system. Eventually, the hardware part of the project was canceled, but the software developments and some of the bus developments led to the CI, the NI, and VAX clusters. My everyday computer terminal was a DEC VT52. This was DEC's first terminal that supported 24 lines of text in both upper and lowercase. Wow! The keyboard on the right spawned the development of EDT, one of the first WYSIWYG, what you see is what you get, text editors. Someone quickly made a hack to Emacs, my editor of choice, to simulate the EDT keypad functions. At home, I built my first personal computer, a Heathkit H8. To go along with that, I built the Heathkit H19, which looked like and was identical to this Zenith terminal pictured here. It wasn't long after that I ended up with my first Apple computer, the Apple II. Remember, Hydra was a 4-year-long project. By the way, Hydra was a low time in my life because I was a supervisor of 2 people doing most of the actual coding work, and I spent all day, every day in meetings for 4 years. Arg. Meanwhile, back at work, I managed to snag a special version of a VT52 that nobody wanted. It looked just like the picture of this VT78 above, but that is another story. The beauty of the new special VT52 was that it contained a small thermal printer on the right side. I found this incredibly useful for matching parentheses and indenting on a rather long and complex program that I was writing during my lunch hours and at night. That would be my first and only chess program. Here's what the program looked like on a VT52 screen. Here's what it looked like on a hard copy terminal like a teletype or a DEC writer. Like this DEC writer. Both our daughters were involved in drum corps. My wife Pat and I would be at drum corps practice 3 nights a week and during the summer every weekend. During a lot of these practice meetings, I was in a break room of a high school working on my chess program. After the Hydra project came the Nautilus project. I became the system manager for that project. That's like a Unix administrator. As the project grew, I was responsible for keeping the operating system running and our 30 hardware and 30 software engineers productive on what would become the largest VAX cluster in the world. At our peak, we had 33 RA81 disk drives in cabinets like the one pictured here showing 3 drives. Each RA81 held 456 megabytes. I know. Wow again. Backup became so important that because of the mean time to fail of each disk drive was 2 years. Extrapolated out, that means that a disk drive might fail every 2 weeks. And they did. We had 10 VAX 11780 CPUs and 2 large auto-loading reel-to-reel tape drives. The operators would run full backups on 1/5 of our 33 disk drives, and they would run incremental backups on the other 4/5 of our disk drives every night during our 5-day work week. This meant that on Tuesday, they would do full backups on the second 1/5 of the disk drives and incremental backups on all the rest. In addition, each night after every full backup, they would run another full backup in case there was a problem reading the recovery tape. Tape drives were saved for 2 weeks. Every week, a truck would haul away 1 week's worth of tape drives to an off-storage site. At home, I purchased an HP 85, which had a built-in thermal printer, and their version of BASIC, which supported some very clever graphics and graph routines. With this, I produced graphs showing the drum corps scores and progress every week. This was my first DEC computer, the DEC Rainbow 100. I decorated our basement in rainbow motif. The monitor on the tube could be raised and lowered with a button on the left pedestal. Our president, Ken Olsen, designed the monitor. It arrived in a pallet in several boxes. The Rainbow cost me about $2,000. Unfortunately for my budget, I soon gave up on the DEC Rainbow because of lack of good software and purchased a Compaq Desk Pro. This was years before DEC was bought out by Compaq. Back at work on the Nautilus project, we started getting Microbax computers, which we placed under our desks. Way cool. I had my own personal Bax computer now. Life couldn't get any better. Did I mention I was building model airplanes by now? Here are my daughters, Kathy and Wendy, holding my Dodgson Love Song glider. Here's my wife, Pat, with our model Japanese Zero. The Nautilus was a huge success, officially named the Bax 8800. Not long after that, I moved from Littleton, Massachusetts to Boxborough, Massachusetts, and eventually to Marlborough, Massachusetts. For a time, my job was to write a program to build CAD layouts by running several individual programs, as in the drawing above. It sounds simple, but when I started, each program was run by someone by hand. I integrated it such that only one VMS command started or restarted the process and maximized the utilization of our Bax cluster to execute as many programs in parallel as it could in batch. It required many hours of compute time for each iteration of each design. The results of the hardware layouts done by this system eventually became all of the next batch of alpha processors that DEC would produce. One of the last jobs I had in DEC was to be a member of the SIMPEST team. SIMPEST was an acronym for Signal Integrity Model Parameter Estimation Tool. It was a way cool graphics program that laid out each etch and calculated the capacitance and inductance between the etch runs. It was a fun project, and many years after high school, I found myself using sine, cosine, and tangent on a regular basis. Who would have thunk it? Although I spent very little time on the problem of hidden line removal, shown above, that all graphics programmers have to cope with, I did spend a little. What I did spend a lot of time on during SIMPEST was creating a program language that allowed our hardware engineers to write routines to model complex hardware in SIMPEST. The lessons I learned way back when I was taking night classes at BU in my first years at DEC now paid off when I finally wrote my first interpreter language, SIL, the SIMPEST input language. Meanwhile, at home, I was learning metalworking. Had to because I wanted to make portholes for a model tugboat. Here's my first milling machine, a Clausing. Here's the second lathe I've owned, a Myford Super 7. And here's my first metal shaper, a Lewis. I was the treasurer of the NAMES, NEMES, which stood for New England Model Engineering Society. Then eventually I became the editor of the NAMES newsletter, the NAMES Gazette. Then I started the Metal Shaper column in that newspaper, which I maintained for 16 years. Eventually I published a book of all of the Metal Shaper columns, which I still sell on Amazon and on Lulu.com. This was my favorite Metal Shaper picture. Here is my Lewis metal shaper shaping a 1/10 scale metal shaper. That is, a shaper creating a shaper. Although I never did finish building that tugboat that I thought I needed a lathe for, I did get into model submarines. This is a model of the USS Pargo. My good friend from work, John Kennedy, served on the Pargo. The Pargo was a Sturgeon-class attack submarine and has the distinction of being the sub that has surfaced through the ice at the North Pole more than any other submarine. My wife Pat and I attended the Model Submarine Regatta in Groton, Connecticut on the New London Submarine Base every summer. Another friend from DEC brought me back a rubber alligator from a trip to Florida. Here I am with the smallest submarine at the regatta, my Ohio-class ballistic missile submarine. Although I never finished the first tugboat, eventually I did create a tugboat. Just before I retired from DEC, I had purchased a Bridgeport milling machine that was a basket case. It took me a year or so to rebuild it, and eventually I published an article on the Bridgeport rebuild that appeared in the Home Shop Machinist magazine in the July and August 2020 and the September-October issues. Here are my 4 books. Next, I'm on to my first fiction book. Wish me luck.